Hello everyone, I'm Sanket Singh and welcome back to my channel. So guys, in this particular video, I'm going to code a very simple but very interesting project. A lot of time you think that how can we make some cool project that make our resume stand out, but we don't know very advanced back end front end stuff. So in that kind of a case, making games is a very easy task. You can code games like Snake, Ping Pong, etc to make your resume super attractive altogether. And in this particular video, I'm going to code our own ping pong game. It's going to be a simple V0 of the ping pong game. We are not going to have a multiplayer interaction. Instead, we are going to have a kind of like a single player interaction altogether. But of course, you can actually extend this game to make it multiplayer using some backend technologies, maybe using Node only. But in this particular lecture, we are going to code this whole application using JavaScript end to end, right? We are not going to use any fancy library or framework. Plain simple vanilla JavaScript is something that we are going to use. This project is going to comprise of some really interesting calculations that you might have to do, and it will also help you to brush up your algorithmic skills as well by making a project. Won't that be cool? So without any further delay, let's just start. Let's start coding our ping pong application. But if you have not yet subscribed to the channel, do consider subscribing to the channel. We are going to bring some really awesome content and a few more projects as well. So let's just start. So guys, before moving forward, there is a very important information that I would like to give you. So recently we wrapped our Elite 1.0 front-end development course, and now we have launched our Elite 2.0 advanced front-end development course. This is a bigger and a better front-end development course that you need. This course doesn't need any particular prerequisite, and we are going to take you from the very beginner level to the advanced level of front-end engineering. We have actually included projects like your own Replit clone, Wix website maker clone, right? Uber clone, and a lot of similar projects. You are going to make your own PubSub library based LLD driven projects, and we are going to make sure that you learn important front-end design patterns as well. I'm going to list down all the projects and all the important design patterns here. This is the only course that you need if you are aiming for SD1 or SD2 or SD3 kind of roles, because we are going to take everything to the very advanced level in front-end engineering. We are going to learn a lot of optimizations, and we are going to see technologies like Next.js, Redux, Zustand, TypeScript, React, and of course, the latest version of React. This particular course is going to make sure that you have ample amount of projects that you can add in your resume. We are going to make approximately 20 plus projects with different variety of complexities, engineering problems, and of course, there will be a lot of discussion around the core concepts of frontend. So what are you waiting for? Check out the course link in the description below, and you can use the coupon code mentioned in the description section to get maximum discount possible. See you guys in the cohort, and let's get back to the video. So now what we are going to do, we are trying to make a ping pong like game, right? What is a ping pong like game? For example, there will be a paddle here, right? And there will be a ball, right? There will be a ball like this. And what will happen? This ball will be moving around, jumping around here and there multiple times, right? It will be taking a jump here and there. What will happen is we will be having a control to move the paddle. This control to move the paddle will be using up arrow key and down arrow key, right? We can give it a extension that this control of the paddle can be done using mouse as well, so that when you move the mouse up, the paddle goes up. When you move the mouse down, the paddle goes down, right? That kind of a functionality we can also build, right? Also, what will happen is, if let's say here is a ball is moving in this direction, when it actually strikes a wall, it should actually reflect back with the same speed, right? It should actually exactly reflect back with the same angle and the same speed, just like following the law of reflection and everything. For example, now it strikes here, it should reflect back like this. And let's say when it strikes the paddle, then from the paddle as well, it will start just, I would say, moving back, right? Also, whenever there will be a strike on the paddle, the movement will change in the X direction. For example, if you consider this as the X axis, this as the Y axis, then whenever a tackle happens on the left side of the ball or right wall, or maybe on the paddle, the X direction of the movement of the ball will change. If the tackle happens on the top or the bottom wall, then the Y direction of the movement of the ball will actually change, right? This is something that we are going to do. Cool. This is the whole agenda that we have in our mind, which we are going to fulfill. So we have these three files, and let's start building a bunch of things. So what I'm going to do is, in order to prepare this whole game arena like this, and we can have a text here, welcome to ping pong, welcome to ping pong, right? What I'll do is I'll wrap this inside a h1 tag, this text inside a h1 tag, right? And then what I'll do is I will be having a div. I will be having a div, right? This is going to be a outer enclosing div that we will name as the ping pong table, right? Or maybe let's not wrap it. Let's have this as the div only. This will be our div. We will call it as ping pong table. This will be our div. Then this circle of the ball will also be prepared by a div, and we will give it a border radius to actually make it circular. And this paddle is also going to be a div. Okay. So let's quickly prepare all of this. So you can see I already have the style.css and the index.js tagged in, right? First of all, let's style a bunch of things. For example, first things first, I'll say welcome to the ping pong game. Then I'll say div ping pong table. And then I will be having let's make it an ID only. Instead of class, let's make it an ID only. And then I'll be having a paddle, right? Apart from that, I will be having a ball, right? I'll be having a div ball. There is currently no content. So if I will go live, you can see nothing actually comes up here, right? I would like to open this in Chrome instead of Safari. So let me bring it on Chrome. Okay. So nothing is actually getting printed here. So we need to do a bunch of styling. By styling our divs, we should be able to see some content. So first things first, what I'm going to do, I'll give a border box. So box sizing is border box. And I will say that every element and all the pseudo elements of that element are going to have a box sizing of inherit. Okay, this is a simple standard regular stuff that we generally make. Okay, and then what we are actually going to do, we will take our ping pong table. We are going to take our ping pong table, and then we are going to give it a border. I'll give it a border of 2 pixel solid black, right? You can see there is a border with 2 pixels solid black, but you can see there is only a straight line. Why? Because this ping pong table doesn't have any width or height. So I'll give it a width of, let's say, 500 pixels, and I will give it a height of, let's say, 400 pixels. You can see now this is how the table looks like. I want to make it a bit more rectangular. So let's say 700 pixels on the width. This is now a bit more rectangular, right? As simple as that. Then let's also try to design our ball and everything. So let's say we have a div with ID paddle, right? I'll give this also a bit of styling. What I will do for the paddle is I will give the paddle a background color of blue. Then I will give it a width of, let's say, 10 pixels because we want it to be a bit slim, and the height can be of around 75 pixels. You can see this is the paddle here. I can give it a margin left, a very slight margin on the left. Margin left as, let's say, 2 pixels. And you can see now it's a bit separated from there, right? Now I'll also style the ball. I'll say hashtag ball. I'll say background color of the ball can be red. I'll say width of the ball is 20 pixels. Height of the ball is also 20 pixels. And border radius is 50%. And this will give us a ball-like feeling. You can see there is a ball here. Okay, looks cool. Now what I'm going to do, there are multiple ways to arrange stuff, for example, using flex and everything. But what I'm going to do, I'm going to use positioning, right? Now what will happen is when we want to move this ball, when we actually want to move this ball, what happens is this ball is technically what? A div only, right? Every div has a property top, left, right, bottom. These properties are present on every div, but by default they are not activated. Why? Because there is a CSS property called as position that actually helps us to activate them. If this div has a position absolute, then what will happen is you can set the top, left, right, and bottom, these 4 parameters of this absolute positioned div. So this will be having a position absolute, and this top, left, right, bottom will be with respect to the first positioned ancestor. Now there is only one ancestor here, which is the div, and then there is the ancestor of the body, right? Now the first positioned ancestor will be our div. So I will give this div a position relative. So what happens if you give position relative? This actually remains in the normal document flow. But when you give this div, the ball, a position absolute, this actually is removed from the normal document flow and is actually placed with respect to the first or the closest positioned ancestor. As simple as that, right? And the same thing I'll do for paddle as well. I will also not place paddle with respect to the body and using flex. I will place the paddle with respect to the corresponding ping pong table, because now this paddle is also a div. This will also be having top, left, bottom, right. So if I will change the top, that means if I increase the value of the top, the distance between the top border of the ping pong table and the distance between the top border of the paddle will increase. If it will increase, it will look like the paddle is actually moving, right? If it increases, it looks like paddle moving. If it decreases, then the paddle looks like going up, right? So that's what we are going to actually do. And I will show you this as a demo as well. So first things first, I'll give the ping pong table a position relative. I'll give the paddle a position absolute. And here as well. If you currently see, now both of them are overlapping within each other. And now what will happen is, if let's say you pick the ball and you say the left of the ball is 20 pixels. Can you see? The moment you start moving it, it's moving with respect to the left border of the first positioned ancestor. And who is the positioned ancestor? Ping pong table is a positioned ancestor. Similar thing for paddle. If let's say I move the paddle top 10 pixel and starts moving it, you can see the paddle looks like moving. If you decrease it, paddle looks like going up, right? As simple as that. This is something that you can actually do, right? And this is going to be one of the most important property that we should try to use, and we will leverage a lot of things using JavaScript on this, right? As simple as that. So I believe this looks good. I'll just commit this one. Git add all, git commit -m, added basic styling and setup for ping pong. Git push. Now what we will do is we will write a bunch of code in our JavaScript, right? A good practice to write this code in JavaScript is going to be, using the JavaScript, we are going to actually use a lot of elements. For example, this ping pong table we might catch, or maybe this ball or this paddle. We have to actually target this using JavaScript, and then we will do some movement. A good way to do is on some particular DOM events. We already know about events. Now, few of the events are there which are actually executed once the DOM loads. For example, there is an event called as DOM content load. DOM content load. What happens is this event is triggered once the complete HTML document has been parsed. That means whatever elements were present in the HTML document, the browser has read all of those. Any of the scripts that were in deferred state have downloaded and executed. This doesn't wait for image load. There will be a image tag that will be processed, but the loading of the image will not be waited for. Subframes and asynchronous scripts, this will not wait for that. So what we are going to do, we are going to write our code of JavaScript as well in that, because since the moment you will start loading the page, the ball will start moving immediately. We don't want a case where our ball is moving, but we are not able to actually we want the ball to move, but the JavaScript has been loaded later, right? Or let's say it loaded earlier and the ball has not been rendered on the DOM, because there can be a case that ball is not yet rendered on the DOM and you execute a JavaScript. That can be problematic, right? So just to keep things safe, so I'll say document dot add event listener. This event listener will be added on the whole document. You'll say DOM content loaded, and inside this, whatever logic you have to write, whatever game logic you have to write, you will write. Okay, whatever is the game logic you want to write, you will try to write it here. Okay. Now I would like to add one very simple, I would say, function, right? I'll say that set interval. What is set interval? If you write any piece of function inside set interval, that is executed after every particular millisecond that you actually mention here, right? Okay, so I'm going to write something here which will be executed after every 1 millisecond. And what will be that? So first of all, I'll say let ball is equals to document dot get element by id ball, targeting the ball element. And what we will do is we will say that let's make two variables. Let ball x is equals to 10, let ball y is equals to 10. What is this? X, or I would say coordinate of the top of the ball, right, with respect to ping pong table, right? The top of the ball with respect to ping pong table, or I should say distance of the top of the ball from the ping pong table. And this one will be distance of the left of the ball with respect to ping pong table. Before we go for set interval, I will say ball dot style dot top is equals to, I'll do a templated string, and whatever is the ball x value, I will put it here and mention a px in front of it, because the top, bottom, left, right, all of these properties are written in form of pixels, right? So what we are giving a initial top pixel and initial left pixel to our ball, right? This is left and this is for ball y. So we are giving an initial top and initial left to our ball. Let's see. And can you see the ball is already a bit on the right side of the paddle? If you increase it to, let's say, 50-50, save it, you can see ball is somewhere here. So what we are doing is, here the ball x and ball y will be helping us to set a starting point of ball with respect to table. Everything is with respect to table. This 50 pixel is not with respect to the top of the page. No, it's with respect to the top of the ping pong table. This is something that you have to always keep in mind. Okay. Now what I'll do is, inside set interval, I'll do one simple thing. I'll define two more variables. Let dx is equals to 2. Let dy is equals to 2. What is dx and dy? Displacement factor in x direction, displacement factor in y direction. And because we are mentioning displacement, if you have learned basic physics, then displacement means the scalar quantity plus the direction. So 2 means, here 2 means you will displace by 2 pixel in positive x direction, right? Minus 2 means you will displace by 2 pixel in negative x direction. Same thing for dy, plus y direction and minus y direction, right? So if the value of this quantity is plus 2, that means you are going to move in the plus x direction, otherwise you are going to move in the minus x direction. And what I will do is, I will just do one simple thing. I will say ball of x plus equals to dx, and I will update the top of the ball. See, I'm incrementing ball x and I'm updating the top of the ball, right? I'm updating the top of the ball, and I will just do one thing. I'll just put one simple check. If ball x is, let's say, greater than 500, then I'll do dx star equal to -1, right? Or ball x is less than or equal to 0. So see what I'm doing here. I'm saying that after every 1 millisecond, increment ball x by the dx displacement quantity. When you update it, update the top of the ball, and one second. I did one mistake. The left should be coordinated by ball x and top should be coordinated by ball y, right? Why top should be coordinated by ball y? Because top means what? Y axis. Top means, if this top means y axis and left means x axis, right? So let's set the left property by ball x and top property by ball y. So here also I will update my left property. And what I'll say that in every 1 millisecond, I will increment the value of ball x by dx, that is, try to make it displace +2 in plus x direction, +2 in plus x direction, right? So I will update the ball left. If the ball x quantity becomes greater than 500, then I will change the direction to -2. -2 means it starts going by 2 units in negative x direction. Or if the ball goes less than 0, then also I will change the direction. Let's see what is happening. Can you see the ball looks bouncing? Ball is properly bouncing here. Can I say that? Right? And if the same thing I do for, let's say, 700 pixels, because the width of my ping pong table is 700 pixels, right? So if I update it to 700 pixels, you can see it just touches this and comes back. But if you will carefully see, let me increase the timer to 10 milliseconds. If you carefully see, this actually completely goes outside of the grid. Okay, it actually goes completely outside of the grid. Let me increase the time a bit more. Right, if you will carefully see, let's not have it this slow. Let's have 50. Yes, relatively better. So you can see it's going to the right, and you just have to carefully see one thing, that it will properly go out of the table. It will properly go out of the table and then bounce back. Just take a look at it. It will properly go out of the table. And why it is properly going out of the table? Because what is ball x? Ball x is updating left of the ball. And what is left of the ball? This ball is actually what? This ball is actually a div, right? So it's, when you say left, this is the left distance. So when it comes here, almost here, then the distance is 700 pixels, right? And that's when it is given a direction to bounce back. But technically, we should not bounce back once you are 700 pixels. You should bounce back when you are 700 pixels minus the width of the ball. Can I say that? See, because when your left comes at this position, then only you should bounce back. What currently you are doing is, you go here, that's when the pixels are 700 pixels, and then you bounce back. But technically what you should do, the moment you come here, what is this moment? This moment is 700 pixels minus width of the ball. Whatever is this quantity, let's say something x. If the left of your ball is x units now, then you should change the direction, right? Okay. Now, what is the width of the ball? The width of the ball is 20 pixels. Let's say if I say 700 minus 20. If I say 700 minus 20, let's see now what happens. The ball is going to the right. I'll just zoom in here. Okay. And now if you will carefully see, it will touch the border and then just comes back. right? Then just comes back. So what's happening when it is touching the border? Let's think about it. What's happening when it is touching the border? So currently, what's going on? This is the table, and let's say this is the ball. Currently, when your dx is plus 2, let's say the left property is currently 20 pixels. What you are doing? You are saying ball x plus equal to dx. That means currently it is 20 pixels. After 1 millisecond, it will become 22 pixels. So when it becomes 22 pixels, you come here. When it becomes 24 pixels, you come here, you come here, you come here. That's what you're incrementing, right? You are incrementing the distance. The moment you come here, you say dx star equal to -1. What does mean by dx star equal to -1? Currently, the value of dx is plus 2. If you do 2 into -1, this becomes -2, right? So now the dx becomes -2. And dx becomes -2 means you are doing ball x plus equals to dx. Let's say the value of ball x is 680 pixels. Now from 680 pixels, you are going to decrease 2 pixels. Decrease 2 pixels, decrease 2 pixels. So this distance is actually decreasing, right? That's the essence of changing the direction of x. Right? That's the essence of changing the direction of x. As simple as that. And now what if I do the same thing for ball y? I'll do ball y plus equal to dy. Ball dot style dot top is ball y pixels. And I will say if ball y is, what is the height of the table? Height of the table is 400 pixels. So if ball y is greater than 400 minus 20, because height of the ball is also 20 pixels. Same logic will be applied here, that your ball will just otherwise go outside, right? Or ball y is less than or equal to 0. What do? You do dy star equal to -1. You change the direction of y as well. Let's save it. And let's make it a bit more fast, 1 millisecond. And you can see we have a very good, properly jumping ball here and there, which is very clean, right? Okay. Now I would like to show you one very simple thing. Let me inspect. I will say document dot get element by id table. PingPong table. Okay. Let's save it in a variable table. Now what is the width of the table? We have already set the width of the table, right? Width of the table is 700 pixels. Now there is a property called as table.style.width. You can see there is nothing in that. So how do we get the width of the table? Although we have set the width of the table in the CSS, but JavaScript will not directly get it. If you want to get it, there is a property called as table.offset width. And can you see what is the value of offset width? The value of offset width is 700 pixels. Similar to that, you have offset height. That's 400 pixels. And that's the height and width of the table, right? So instead of saying 700 here, let me comment this line. And what if I say if ball x is greater than, let's get the table in our script as well. Let table is this. If I say table dot offset width minus, now what is 20? 20 is the width of the ball, right? How can we get the width of the ball? If I say ball if I say ball dot offset width, can you see the width of the ball offset is 20, and all of this width is actually calculated based on border box, right? Box sizing as border box. So now I will say ball dot offset width or now you can see I have done here ball of x is less than or equal to 0, right? if you do something like table dot offset left, can you see what is offset left? Offset left is coming as 8. Now what is offset left? Offset left is the distance between this div and the nearest positioned ancestor. But we don't want that. We know that this ball is actually positioned with respect to the table. So when you say ball x is less than or equal to 0, then what do you mean? You mean that when the distance between the left of the ball and the left boundary or the left border of the table is less than or equal to 0, then you have to do some action. And what action you have to do? You change the direction. Change x direction. And similar thing I will do for y. I'll do copy, paste, but this time this will be table y. Instead of offset width, this will be offset height. And this will also be offset height. And this time I'll do dy minus equal to 1, ball y less than or equal to 0, y direction. Here ball y less than or equal to 0 means when the distance of the top of the ball is less than or equal to 0 from the top of the border of the table. If I save it, you can see still after saving, everything is absolutely same. Everything is absolutely same. And what did I do? What did I do? See, previously I was doing 700 minus 20. Why? 700 was the width of the table. 20 was the width of the ball. So this calculation we did, I am saying that if you want to get the width of the table, instead of hard coding it, there is a property called as offset width. You can get the width of the table using offset width. You can get the width of the ball using offset width. So I'm just replacing these two properties here. And same for the height. 0 remains as it is. 0 remains as it is. So now you can see we have a properly moving ball, or I should say a properly bouncing ball. Let me commit all of this. Added bounce to the ball. Here we go, right? A lot of you guys might be having confusion in offset width and offset height, that why do we need it? Why can't we hard code it? See, here we have a ping pong table. What if I do min width as 700 pixels? When you do min width, that means that at least 700 pixels should be allocated or more, depending on the size of the parent. If I save it, can you see now the table is a way longer table, but you will see that our logic is still intact, because if we will hard code 700 here and the size of the div increased, then we don't know what is the size of the div. So if you want to get the live size of the div, for example, let me decrease the size of the div. See, now I'm decreasing the size of the div, and if I keep it here, see, everything still now works. So if you want to get the live size of the div, that currently what is the size of the div or width of the div, you do table.offset width. Same thing for height. But although we have a fixed width and height here, so even hard coding works, but this is the best way to go for. Now let's make the paddle move. Let's make the paddle move. So I'll target the paddle as well. Let paddle is equals to document dot get element by ID. Paddle. Targeting the paddle element. And I will attach a listener to the paddle. Let me do that here. I'll say paddle, and technically not a listener to the paddle. I will attach a listener to the document. Document dot add event listener. We will add an event that at any point of time, the key down event is pressed anywhere in the document. At any point of time, the key press event is pressed. So what happens in the key press event? Let's make it 100%. So in the key press event, generally, if you do a down arrow key, it starts scrolling, right? So what should happen in the down arrow key press event? I will get the event object. What should I do is, I can actually check which key was present or which key was pressed. How? If the event dot key code is equals to 38, then we can say that the up arrow key is pressed. Let's do a console.log. inspect. If I press a up arrow key, you can see up getting printed, right? Else if event dot key code is equals to 40. 40 is the down arrow. Okay, 40 is the down arrow. Now, just like how I have ball X and ball Y, I will also keep let paddle Y is equals to initially 0. Right. And I will say that let D paddle Y, or let's say, yep, let's say DPY, okay, is equals to 5. This is what? Displacement for paddle in Y direction. And again, the same thing will happen. If displacement is plus 5, paddle will go down because the top will increase. If it is minus 5, paddle will go up. What we should do is, we should say paddle Y plus equals to DPY. Right. Otherwise, paddle Y plus equals to minus 1 into DPY. And every time I will say paddle dot style dot top is equals to paddle Y pixels. Let's do it. So now if you see, can you see both of them are moving? Can I say that? It's actually moving, right? And what is currently happening? When you increase the height, let's say console.log, let's do a console.log here. Let's see what is happening. I'll say up, and then I'll imprint the paddle Y. So one weird behavior is happening. So let's see. If I press the, sorry, my bad. If I go here, I press the up key. Can you see? When you press the up key, the paddle is increasing, right? When I'm pressing up, the paddle Y is increasing. But technically, when I press up, it should decrease. It should go in the up direction. So we should replace it. I should do minus 1 into DPY here. And I should do DPY here. DPY here. If now you will see, if I'm going down, this is going down. But if I go up, you can see in up it is decreasing. This is the correct behavior that we want. And one more thing we don't want is that if you press the up arrow key, right? And, or I should say it like this, and paddle Y is greater than 0, then only you should bring it up. Okay. So now currently if I press up, nothing will happen. I'm pressing up, nothing is happening because I have set it to the fact that if the paddle Y is greater than 0, that means somewhere here. Now currently it is greater than 0. Now if I press the up key, see, it goes here and now no more, it will not go up. Same thing I should do here, that, and we should only go downwards if paddle Y is less than table dot offset height. Can I say that? That if it is less than the height of the table, then only it should go down. Let's see what happens now. So if I press down key, down, 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 there will be a weird behavior that we actually know why is happening. If we go come here, can you see it is able to still go down, and now it stops. Now I'm pressing the down key, doesn't go down. Why is that? Because the top property is from this top of the div to the top of the border. What do we need to do? We are having an extra increment of the height of the paddle. So what if I say minus paddle dot offset height? Similar thing that we did for the ball. Instead of the ball, I'll do it for the paddle. And here you go. You can see it doesn't go beyond this, right? It doesn't go beyond this. As simple as that. So now our paddle is also moving. Let's quickly commit this. Making the paddle move. Sorry. Making the paddle move. As simple as that. Now, one weird thing that you will see happening is that if you press the down key, let's say if I refresh, if you actually go like this, if you press the down key, there is a scroll happening. See, up and down, the scroll is also happening. Why? Because that's the default behavior of the up arrow key and the down arrow key, that if there is a scroll available, it will start scrolling. But I don't want that. So for every event, for example, mouse over, for key press, every event, there might be some default behavior already present. For example, there is an event of form on submit, right? Now there can be a case that you want to submit the form, but you don't want the page to refresh, because generally on form submit, page refreshes. So what you can do is you can prevent the default nature of the event by calling event.prevent default. What this line will do is this prevents the execution of the default event behavior. Save it. Now if you go here, you can see now I'm going downwards, no scroll is actually happening. As simple as that. Now the only thing left is we need to detect the collision of the paddle and the ball. We need to detect the collision of the paddle and the ball, right? Okay. How can we do that? So let's take the paddle element. Okay. If I do a paddle here, you can see this is the paddle. There is a property called as paddle dot offset left. Can you see there is a property of paddle dot offset left? Let's see what is that. Can you see this is 2 pixels? And if I go here and increase the margin from 2 pixels to 20 pixels and try this again, can you see this has been increased to 20 pixels? So what is offset left? What is offset left? If let's say this is the paddle for any div, let's say for the paddle or the ball, if you try to get offset left, this is the distance of the left side of the div to the nearest positioned ancestor. And what is a positioned ancestor? This table is the positioned ancestor, which has a positioned relative, right? So if let's say at every point of time, if you just print console.log ball.offset left, save it. Can you see when ball is coming on the left side, offset decreases. If it goes on the right side, offset increases. And this offset is with respect to the closest positioned ancestor, right? So what I will do here is I will go back with the CSS to margin left. What I will say is that let's try the detection of the collision of ball and pedal. Okay. Now what we should do is we should check that if ball x is less than, if the value of the ball x is less than what? First of all, there is a slight width, that is the margin left. We should first of all accompany that. That is paddle, and we should put this logic above because collision on the paddle can happen before. I'll say paddle dot offset left. This is 2 pixels plus Apart from this, apart from these 2 pixels, you need to check the width of the paddle as well. So I'll say paddle dot offset width, right? If ball x becomes less than this, if ball x becomes less than this, then what you should do, you should then also do dx equal to -1. Rebound the ball. But that's not all. That's not all. Now what will happen is, you will see every time ball will never touch the wall, right? So we should also check that ball should collide like this. So I'll rub all of this. If this is the ball, it should not be like, it should just check this distance, that okay, oh, it is now have the ball x is less than this plus this, so we should bounce back. No, it should only bounce back when the y is also within this range, that it exactly collides here. When do you know it exactly collides here? When the x is within the bounds that we just mentioned, and top of the y is greater than or equal to top of the paddle, and bottom of the ball is less than or equal to bottom of the paddle. That's when you actually know. So let's calculate. So one more thing is, I would like to increase the width of the paddle just for better demonstration. Let's say I will make the width of the paddle as 20 pixel. Now the paddle is a bit wider. Okay. And if I decrease the speed of the ball, for example, 50 here, right? Let's close it. And we will closely monitor the region where the ball is going to collide, so that I can justify my argument for the y direction. Okay, let's wait. It's too slow, but it's almost done. Okay, so it collides on the bottom, and if you carefully see, can you see it just came back? It never touched the wall. Why? Because we just have the check for x, but just this check of x doesn't work, right? We need to say and I'll put more conditions. What more conditions? I will say that the ball y should be greater than paddle dot. How can we get the top of the paddle? I can say offset top. Just like how we got the left of the paddle, you can also get the top of the paddle. If ball y is greater than paddle dot offset top, and ball y minus ball dot offset height. So ball y is what? Ball y is the top of the ball minus the height of the ball. If this region is less than paddle dot offset top plus paddle dot offset height. What does this quantity give? Paddle dot offset top is actually this quantity, this top. Paddle dot offset height is this whole height. So the sum of all of this actually gives the paddle dot bottom. It gives the bottom of the paddle. And now, if I save this, let's see what happens. We will wait for the ball to come back, right? We will wait for the ball to come back. Okay. And if now you carefully see, it is going properly behind, right? And let me increase the speed of the ball now. It's too fast. Let me see if I can hit this time. No, the paddle is too slow. Oh man, the paddle is too slow. Let's increase the speed of the paddle. The speed of the paddle, I believe, can be 10. Now you can see it's bouncing over the paddle. Can you see? It's now bouncing over the paddle. Here we go, right? But currently the control of the paddle is too, I would say, cumbersome. I'll give you a better control, but I believe very easily we have added the logic for collision of the paddle. Added paddle collision logic. And I'll just quickly explain the logic. I'll quickly explain the logic once more. What is the meaning of this quantity? This quantity is what? This compares if left of ball, and when I say left, this left is with respect to table. The left with respect to table of ball is less than right of the paddle, and right with respect to table. Right with respect to table. Right? So see, let me draw it a bit more in a wider way. Let me draw a wider one. So let's say this is your table. Let's say this is your table. This is, let's say, your paddle. Right? This quantity is paddle dot offset left. This quantity is paddle dot offset top. Right? This quantity is paddle dot offset height. This quantity is paddle dot offset width. Okay. Now let's say you have a ball. Right. When the left of the ball, see, you say ball X, right? What is ball X? Ball X is the left of the ball. If the left of the ball reaches here, and what is this point? What is this point? This point is paddle dot offset left plus paddle dot offset width. Can you see? Paddle dot offset left and paddle dot offset width. If the left of the ball becomes just less than this, it should bounce back. It should bounce back. That's why I said left of the ball is less than right of the paddle. Can I say paddle offset left plus paddle offset width is actually what? Paddle dot right. That is the right position of the paddle. Then if you do this quantity, you can say if top of ball, if top with respect to table of ball is greater than top of paddle, and this top is with respect to table. So what this condition says that now if you will not put this condition, if you will not put these two conditions, what will happen is even the ball is here, even let's say the ball is here, here also, can I say ball is crossing the right of the paddle. If the ball will come here, then also it will reflect back, but we don't want that. We want the ball should reflect only if it actually collides on the paddle. So to detect the condition of actually colliding on the paddle, it should be within this range only. If the ball is colliding on the paddle within this range, then only we will say. So now this condition says that check the top of the paddle. If the top of the paddle is actually greater than, if the top of the ball is greater than top of the paddle. What is top of the ball? Top of the ball is this distance. Right? This will be the distance of top of the ball. And this is the distance of top of the paddle. Offset top is what? Distance between top of the paddle and the top of the table. If the ball is in the region greater than this, that means definitely it's below this region. And then the third condition, which is this. We say if what is ball y minus ball offset height? Ball y minus ball offset height is what? This is ball y. So this is ball y and this is ball offset height. Can I say? Right. So I will say ball y minus ball offset height. So technically we don't need ball offset height. We don't need this ball offset height, do we? I believe we need to check the ball bottom, right? That the bottom of the ball should be on the paddle. So I should do plus. Instead of minus, I should do plus. Okay. I should do plus. Let me explain why. What is ball y? This is ball y. What is ball height? This is ball height. So ball y plus ball height is what? Ball bottom, right? This is bottom of the ball. And you say that if the bottom of the ball is less than, what is this? What is this? This is actually bottom of the paddle. Can I say that? How it's bottom of the paddle? Paddle dot offset top plus paddle dot offset height is actually bottom of the paddle. So you say that if bottom of the ball is less than bottom of the paddle, that means ball is somewhere here. So ball is in this region and it actually tries to go beyond this limit. Sorry, the ball is in this region and it goes beyond this limit. Then only we will consider the collision with the paddle. And here we go. Now it should work even smoother. Sorry. See, now it's coming back from the paddle, right? Now we want a better coordination with the ball. So better coordination of the ball can be taken by mouse. That if we scroll the mouse, then we should get a better coordination, right? So what I'll do is, I will say document dot add event listener mouse move. What is mouse move? Mouse move is an event which triggers the moment you move the mouse. The moment you actually move the mouse, that's the mouse move event. And in this event, you have a property event dot client y. What is event dot client y? This is the, I would say, y, or I would say this is the distance of the mouse pointer from the top of the screen, or I'd say top of the browser. Okay, so if you do console.log on this, inspect. Oh, my bad. Now you can see the moment I go up, this value is decreasing and this value becomes 0 here. If I go down, this value is increasing, right? As simple as that. So we can get the top of the mouse value. Okay. So I'll say let mouse distance from top is equals to this. Okay, cool. So we got the distance of the mouse from the top. Okay, as simple as that. Now I will say that, what if I say table dot offset top? What is table dot offset top? One second. We have a table property. Yes. So technically we should say it like this. Let table is this. When I say table dot offset top, it's 80. What is this table dot offset top? This is the distance. This is the distance of the top of the table from the nearest positioned ancestor. But can you see there is no one beyond the ping pong table which is positioned. So it will take it from the body. So this 80 pixels is this distance, right? This 80 pixels is this distance. So let distance of table from top of, also from top is equals to table dot offset top, right? Table dot offset top, right? So now what we will say is that, we will say if paddle y, if paddle y is greater than 0, and paddle y is greater than 0 means the distance of the top of the paddle from the top of the table is greater than 0, and very simple equation I will write, or let's write it like this. We will say if paddle y is less than 0, that means the distance between the paddle and the top is less than 0, or we should say less than or equal to 0, or the paddle y is greater than table dot offset height minus paddle dot offset height. What is table dot offset height? It's the height of the table. If you subtract height of the paddle, then you are actually getting somewhere here when the bottom of the paddle is touching the bottom of the table. If this thing happens, then you return, then you don't need to do anything. If bottom of the paddle touches bottom of the table, return. Okay, as simple as that. Otherwise, what we are going to do is we will say let mouse point control is equals to, I will say distance of the mouse from the top, right? Distance of the mouse from the top we will calculate, right? Minus distance of the table from the top minus paddle dot offset height by 2. This is the mouse point control that we will compute, right? Let's try to do a console.log here. Mouse point control. If you will carefully look at it, one second, you can see when we are here, when we are actually somewhere here, you can see 0.5 and minus 0.5 we are lying, which is at the middle of the paddle. Can you see? At the middle of the paddle we are approximately 0, right? And how is that? What we did was we said mouse distance from the top. So currently what will happen is, if this is your mouse pointer, right, consider this as your mouse pointer, then this is the mouse distance from the top. I subtracted distance of the table from the top. So this is the mouse distance from the top. I subtracted table distance from the top. You can see table distance from the top, and I got paddle dot offset height by 2. That is this much distance. So I decreased this much distance as well. And that's the mouse point I considered for the middle of the corresponding paddle, right? And now what I'll do is I will say paddle dot style dot top is equals to mouse point control pixels. That's it. If now you see we are able to control the paddle, there is a slight issue. We'll just rectify that. So let's remove the console.log. We did it. Let's save it. And now you see when you go up, when you are going up till here, you are able to move the mouse. If you are able to go down, you are able to move the mouse, but you can move the paddle beyond the direction as well, right? We are able to move the paddle beyond this point as well. That is not something that we actually look for. So this update we should do beyond the return. So we should do this update here. What will happen is it will calculate, are you going to move the paddle beyond the table? If yes, then you don't move it, you return, otherwise you move it. And now let's see. Let's save it. And we can actually do two things. We should say paddle y is equals to mouse point control, and we should actually update always with paddle y. And now you can see, there we go. We are able to control the whole paddle, right? Let's see where it comes. Oh, sorry, I missed it. You can see now it bounced back. It bounced back again, right? So that's what we did. So simple mathematical calculations we are doing, and we are able to achieve most of the stuff. Added paddle movement by mouse. Okay. And now you can do one more thing. If let's say there is one more paddle, you can actually see event dot client x. There is a property event dot client x that will tell you what is the distance of the mouse from the left of the screen. And doing some computation, you can calculate half of the table width. And when your mouse is beyond the half of the table width, then this paddle should not move. Instead, your other paddle should move. You can put a paddle here, right? For example, you can do something like this. If event dot client x is greater than table dot offset left plus table dot offset width by 2, then also let's say you return. Okay, let's see what happens. You can see currently I'm controlling it here, but if I go beyond the half of the distance, now it's not controlling it. Now it's not controlling it. See, when we are here, then it will control it. If you go here, then maybe you can make the other paddle get the control. So that thing you can actually do here, right? Also, one more thing, sometimes you will see that the ball goes completely inside the paddle. I'll tell you the reason for that. So you can see just it goes completely inside the paddle, but I'll see one more situation. Now it doesn't go. So what happens if during the collision, if you are making the paddle move, then all of this computation happens once again, right? That's why it has to recalculate it. That's the jitter that you see. But if the paddle will be stable somewhere and it's not moving when the ball collides it, then you will not see that. You can see, you not see that. And you can see a good working ping pong model is actually working for us.